Now, solving with logs, we are going to make sure we get the log by itself and then convert it from log to exponential or exponential to log. When we convert this from a log to an exponential, the base is 6. That's our base. The -1 is your exponent, and that equals 2x plus 1. 6 to the -1st is 1 over 6. Subtract 1 to solve this. We get 1/6 minus 1, which will be 6/6. It's -5/6. Then divide by 2. When you divide, it just goes onto the bottom. You multiply it to the bottom, so that's -5 over 12 equals x. Plug it in just to make sure we don't have an extraneous solution by having a negative inside the parentheses. 2 times -5/12 would be -10/12 plus 1. -10/12 plus 1 is positive, so it's good. Because it would be -10/12 plus 12/12. Number 9, we're going to do the same thing. We're going to convert this to a exponential. So base is 8. Two-thirds is the exponent. Eight to the 2/3 power we can work out. So 8 to the 2/3, that's a number we can work it out. Remember, the 3 is the cube root of 8. So that's 2. Cube root of 8 is 2. 2 squared is 4. So 8 to the 2/3 is 4. So now it's an x squared minus 3x equals 4. We want to move the 4 over since it's a quadratic. We're going to move the 4 and solve by factoring. So factor this. That'd be x minus 4, x plus 1. Tee it up. X equals 4, x equals -1. Plug it in to make sure we don't get an extraneous. Plug in 4, we get 16 minus 12. 16 minus 12 is positive, that one's good. Plug in -1, that's 1 minus 3 times -1, that would turn to plus 3. That's positive, that works out also. Both good answers. Keep going. So we need to solve this one. Since there's not a log, it wouldn't make sense to convert it to an exponent because they're already exponents. But we can rewrite the square root of 7 as the 1/2 power. And we've got 7 to a power equals 7 to a power, so the 7's just cancel and the powers are left. So you get 2x minus 1 equals 1/2. Add 1, you get 3/2. Divide by 2, which is like multiplying by 2 to the bottom. X equals 3/4. If you plugged it back in, there'd be nothing wrong with it, so it's a good answer. It's not extraneous or anything. Number 11 is about the same thing as the last problem. We need to convert them so they're all base 3. We have 3 to the x equals 27, which is 3 cubed. times the square root of 3, which is 3 to the half. Since we're multiplying things with the same base, you add the exponent. So we get 3 to the x equals 3 to the 3 plus 1 half. If you just put it as a fraction, it's 7 halves. Then since the bases are both 3, they cancel out. We're left with x equals 7 halves. Number 12, to solve this, we're going to convert it from a log to a exponent, where the base is 3. The answer of a log is the exponent, equals x. 3 to the 4th, 3 times 3 times 3 times 3, that's 81. Number 13, same thing, convert it to an exponent. So the base is x, so you keep the x as the base. 2 is your exponent, equals 25. Square root both sides. Technically, you get plus or minus 5, but you can't do a negative base on a log. So it's just positive 5. So we got a log, we got to convert it to an exponent. So that's base 32 to the 2/5 power equals x. So we just have to figure out what 32 to the 2/5 power is. So we take the 5th root of 32. So if we did 2 times 2 times 2 times 2 times 2, that's 2, 4, 8, 16, 32. So the 5th root of 32 is 2. So then that's 2 squared, which is 4. X equals 4. So log base 6 of 1/6 equals x might be easier for you to solve if you convert it to an exponent. So that's 6 to the x equals 1/6. Once you see it that way, hopefully you can observe that since the 6 is on the bottom, that's a negative exponent. Then 6 to the negative first. You can change 1/6 to be 6 to the negative first equals 6 to the x. Since the bases are the same, x equals -1, and done. Now, you just can't put negatives in a log. They can equal in it. 13 wasn't extraneous. Oh, you just can't do a negative base. Like, you can't do log -5. Sweet.